So I wanted to talk about really two things. I wanted to talk about open source, which is a real passion of ours at Cloudsoft, and then drill down on a project that we're heavily involved in called Hyperledger. So, probably the last time I'll get to say this on the stage of Defrag, because as you all heard, it's merging with Glucon, and I'm sure it'll be even bigger and better as a combined event. But we see open source and contributors, committers, users of open source as really part of a movement which I would sum up as being 21st century alchemy. So what is that? Well, the definition of alchemy is taking lead and turning it into gold. That's one definition. Unfortunately, we haven't worked out how to do that yet. But the other is working together, it's code, it's community, it's culture, bringing all that together to create something new and bigger and better than us individually. So, who's not heard of the Linux Foundation? Good, okay. We're amongst friends here. So, the Linux Foundation, hugely influential. As I'm sure you all know, Apache Software Foundation really marked the beginning of the open source movement, but the Linux Foundation has done a tremendous amount, especially over the last few years, to really bring on many, many projects. There's just a couple here. Cloud Foundry, brilliant project, now has its own foundation within that umbrella organization. And in fact, I'm pleased to say, and this is brand new, hot off the press, Abby Kearns will be becoming ED, Executive Director of the Cloud Foundry Foundation, as of about 3 minutes ago. So, how about that? We know what Sam's going to be doing. We know he's got an interesting, and he said, I've got a fantastic opportunity, I'll be telling you all about it, but after 2 phenomenal years at the helm, we're really, really happy, he's happy, Abby's happy, that we've got that transition, that graceful handover in place. So, Hyperledger. So the Hyperledger project is probably fair to say one of the most successful Linux Foundation projects. It's not even a year old. Huge, huge interest from not just technologists, vendors, but importantly, end users, consumers. So, massive project, really the home for a number of separate projects. We're going to talk about one, the Hyperledger Fabric, but that's just one of about a half a dozen. So you can expect this project to grow from strength to strength and really to create all the tools we need to actually roll out and work with blockchain. So I mentioned the Apache Software Foundation. The executive director of the Hyperledger project, Brian, was actually one of the prime movers for the original Apache Web Server. And Apache Web Server was the first project to be contributed to the ASF and really gave birth to the ASF. So I said there's a tremendous amount of support. The way these collaborative projects work, there is a sort of premier, sort of board level involvement, and you can see the companies there. I believe this is accurate. I mean, every week or every few weeks there are new announcements about new members and so on, but basically the core premier tier really provides the governance around the project. But then there are a lot of other companies, and obviously Cloudsoft's included in that are then supporting this initiative. So you've all heard, I'm sure, of blockchain in the context of Bitcoin. But what's important to understand is that Bitcoin is just one application of blockchain. And so what's happened, and what really the Hyperledger project is all about, is saying let's extract or separate out or delaminate between applications and infrastructure. And let's build out the actual open source blockchain technology, specifically aimed at business. And the big difference there is that you're going to work with a permissioned blockchain network. So you've all heard, I'm sure, of mining and so on and so forth. That's really tied in with the unpermissioned or the promiscuous blockchain networks like Bitcoin. But what we're doing in the business world is saying, we'll set it up so that there is membership, it's well defined, it's still very secure, but you can have many, many, many different blockchains. And later we'll give you an example from Sotheby's in the UK. So why do you need something like blockchain? Well, the traditional approach that people take with, let's say, asset management, for example, is everyone has a view as to who owns what. And most of the time that works. But when it doesn't work and when it goes wrong, it can be really catastrophic. So you have individual institutions. If this is a financial services model and you've got asset management is an asset class, you want to know who owns what share or what instrument, then why do we all repeat that exercise as individual institutions? And by the way, there's a real cost of doing that. So it's been estimated that the cost of every financial institution maintaining its view of who owns what credit default swaps costs the industry as a whole $2 billion a year. So this is real money we're talking about here. So the idea instead is to create a blockchain which is, at its heart, a distributed ledger that ensures that through a consensus algorithm and the various types of consensus algorithm, that you actually all agree who owns what or what transaction happened in what order, so it can be sequenced and so on. So I talked or hinted at wanting to really focus on one of these projects. It's really one of the foundational projects, the Hyperledger Fabric. Like all projects in the foundation, it's currently in incubation. The original code was actually contributed, or a large part of that code was contributed by IBM. But there are now many, many people working on this code. As it says here, and this description is somewhat abstract, but we'll get into a real-world demo in a minute. But the idea is that it's using tried and tested technologies. It's using containers. It's using many of the technologies that we're familiar with in the cloud-native world, and it's putting those together in order to host not just one, but many different smart contracts. So a smart contract is a piece of code, essentially, that governs some behavior. Sometimes you'll hear us refer to it as chain code, but think of it as an application that's actually hosted or running in that blockchain network. So one of the really cool things about Hyperledger is you can load it up with many different chain codes so that you can run multiple applications simultaneously. And that's very important if you want economies of scale. And one of the things that's being posited by people is that this will give us a new basis for a transactional web. So it could be as significant as the introduction of the original web in 1994. As I said, it's permissioned, so that means that your membership is something that is handled as a very specific function, so you know exactly who's participating in this. So, a good example would be, back to the thing I talked about a minute or two ago, I want to ensure that across an industry, we have a common, considered, agreed view about who owns what. Well, use the Hyperledger Fabric, write an application, roll it out, and then everybody can interact with that. So I promised that Mike would join us again in a few minutes' time to give a demo. So one of the things we've observed, and I'll give you a couple of slides on Cloudsoft in a second, is that a lot of the tools that are given to developers who want to experiment with and develop blockchain are great if you're working at home, on your laptop, whatever, but they don't really model the real world. So if we're talking about a distributed global blockchain, let's roll out a distributed global blockchain and use that as the test bed. So of course you can develop code against a 5-node cluster using Vagrant running on your laptop. Nothing wrong with that, but it's not quite what we're going to encounter in the real world. And because blockchain is based on, or your blockchain will be based on a specific consensus algorithm, that means you have to have communication between the validating peers within that network. And so it's very easy to fool yourself into thinking something is working if you're doing it locally, and we all know that that can actually give you misleading information about the performance of the network and so forth. So very briefly on us. So our focus is on management, so hands up, I'm not a blockchain expert, and I have no desire to become one. It's my job and our job as a company to support that particular domain. We obviously have an appreciation of and understanding of how blockchain works, but we're not setting out to be a vendor of blockchain applications or services. Instead, we see our role as very much providing the support you need to actually manage these networks. And for us, that's very important. It means that you're actually being able to not just deploy something and then walk away, we're actually able to constantly monitor it and manage it, and preferably do that closed loop. So we're big fans of and pioneers of something called autonomic computing, which, when we started thinking about that many years ago, was pretty hard to actually implement, but now with the prevalence of APIs, with the substrates that we have, the technologies we have today, there really is the possibility of doing closed loop management. So this is management or automation which enables you to scale what you're doing. So open source, I said, is important to us. We created a few years ago a project called Brooklyn. We chose that name because it epitomizes a bridge, and we think of bridges as being very important, whether you're bridging from the old world to the new world, whether you're bridging between different locations in some kind of hybrid or multi-location environment. But notions of bridge are very important to us. And so Brooklyn became an Apache project 2 or 3 years ago, and it graduated about a year ago and became, actually almost exactly a year ago, a top-level project. So one of many, many projects, of course, but we're delighted there's now a community of people working with Apache Brooklyn and also working with us commercially as a company in order to sort of move this forward. So how does Apache Brooklyn or AMP work? Everything starts with a model. So the model is the blueprint. So exactly the same way you have a blueprint for a house, and that blueprint can be taken and you can then build your house on a particular terrain, and that terrain may vary. So we believe blueprints should be independent of assumptions about the underlying infrastructure, be it Amazon, be it Azure, be it Google, be it IBM, or be it an on-prem environment. It doesn't matter. The point is separate out the concerns of the blueprint, capturing everything you need to know about your application or service. Obviously, in this case, we're talking about a blockchain network. That means all the components that make it up, how they fit together, what dependencies there are, et cetera, et cetera, et cetera. And then take that and then late binding decision, decide, today I'm going to deploy that in a particular environment. And once I've deployed it, of course, I want to then proactively manage it. So you instantiate your model. So if you're an object-oriented guy like me, that means you've taken a class and you've now created an object. You then monitor the environment. All that sense data you then use to decide when and where and how to then manage or proactively change your application. So shape-shift it to fit the prevailing circumstances. So what's that got to do with blockchain? Well, I've sort of hinted at this already, but the 2 key areas, and here's a sort of laundry list from one of the subject matter experts at IBM Blockchain Labs, just calling out the different components. And the ones that we're obviously interested in are the consensus network itself, so Hyperledger Fabric being such a thing, and then the management of that, and then finally the deployment to that. So there's 3 things. There's the management, there's the network, there's the deployment and management of that network, and then there's being to deploy or inject applications, blockchain code into that network. So this is a brilliant schematic capturing all the key elements here. At the center you have the blockchain network. This consists of some number of validating nodes or peers. So they're the ones that actually create or agree the consensus about whether to admit a transaction, whether it's a legal transaction and so forth and so on. The way you interact with that is at arm's length. So you actually create an application, and that application uses a non-validating peer as the gateway into that network. So the core network is super secure, and that's really important. So because that is where all of the state is maintained across that network. And so the ingress and the egress from that network is something that has to be carefully controlled. It's done through an application that then talks to a non-validating peer that then connects through to that network. And we'll show you that in a minute or 2. So I've just preempted myself. This is a slightly more sort of broken out way of describing exactly what I just said. So we're going to show you a client. In fact, we've got 3 clients. They each have different functions, and those clients are then going to interact with the blockchain network. In the interest of time, we'll have already set up the blockchain, deployed it, and so on, and primed it. And then we'll have 3 different persona interacting with that network. But they're all doing it through this mechanism. So it keeps the core blockchain network super secure. And this is a super expensive graphic that shows us deploying a blueprint. So enough of that, Sotheby's. So, hands up, who's a fan of David Bowie? Okay, who was at Sotheby's? Did any of you buy one of the lots? Sadly, I couldn't even meet the reserve on anything, even a vase. But the key thing about this demo is it was a very, very successful auction. Every lot sold because of the provenance, because of who had owned these artworks, many of which are great in their own right. In all cases, the reserve price was well exceeded. But in this scenario, we have three people that really hoovered up all of those artworks. Charlie, Dave, and Edwina. Those are not their real names because they're actually quite shy, retiring high net worth individuals. But anyway, Charlie, Dave, and Edwina, very tech savvy, and having between them bought up this collection, and obviously at that point dispersed the collection, were very keen that in some sense it remained together. So their idea, and this is what they came up with because they'd obviously read about blockchain, was, hey, Sotheby's, can you just create a blockchain network, load in all of those works, and we won't necessarily trade, but we'll transfer them between each other so that we can make sure that we can actually share and enjoy all of these artworks over time. So rather than just having, I've got 16 out of the 47, somebody else got 16, and somebody didn't luck out, they ended up with less. I think that's right. Anyway, 47 divided by 3 doesn't go. But anyway, Sotheby's, very accommodating. Alice sets up this blockchain code. She makes Bob the administrator. Bob essentially was handling the auction. So Bob inputs all of the data. So which of those paintings or works of art, because they weren't all paintings, went to which? Went to Charlie, Dave, or Edwina. And then once he's done that, it's all set up. It's then really up to the three of them to interact with this. So to do that, they use an asset management demo that comes with the Hyperledger Fabric. And so that has a small handful, this is typical, by the way, of a smart contract. There's a small handful of operations or transactions that you can actually do with this application. So initialization and assignment are the two that are used by Alice and Bob respectively to set up the network. And then what we get into is using two basic behind-the-scenes transactions, transfer to move ownership from Charlie to Dave or Dave to Edwina, and then query to just sanity check everything has gone to plan. So without further ado, I'd like to welcome back Mike to the stage, and Mike and I are going to just show you how that works in practice with the help of Charlie, Dave, and Edwina. In your own time, Mike. Okay, can we fade to the laptop, please?
Cool, all right. Yeah. Sweet.
So what have we got running here, Mike?
Cool, so yeah, you guys can hear me well? Basically, a couple of things you mentioned I want to quickly show in practice. So basically, modeling a blueprint for something and deploying it. Here we can actually take a look at the live model of the Hyperledger Fabric running. That was once a blueprint. It was then deployed by AMP to IBM's Blue Box, and now it exists in reality. We can see a model of it running. So basically right here, we'll open up in the inspector. This is AMP4, a new UI we released relatively recently. This is a Hyperledger Fabric multi-cluster. What that means is basically there are validating peer clusters in 3 different geographies, San Jose, Singapore, and London. They're all in the same blockchain network, but they're geographically distributed. And this can be likened to different organizations. There's a bank in San Jose, there's a bank in Singapore, a bank in London. They want to be part of the same blockchain. Now they are. They're communicating together. Also, other components you have is just a root validating peer, which effectively is the same as all the other ones, except it knows about which other peers exist, and membership services and CLI. Membership services handles authentication.
So these are all standard Hyperledger Fabric building blocks?
Yeah, absolutely. These are all actually containers that have been published by Hyperledger that we are firing up. And so this basically shows you a live model. You can see the health of it. You can see the addresses at which they exist. All these kinds of information can be consumed right from the console. So that sort of shows you the live model.
So I think it's worth mentioning, when I said at the beginning we wanted to be able to deploy global networks, blockchain networks, this is an example of exactly that. So as Mike just said, we're targeting 3 specific areas. We're using BlueBox, which is an OpenStack private cloud that IBM provides. I think it's been remarketed now as Bluemix Private Cloud, but it's the same stuff, basically. But the idea is that those three clusters have all been fired up, and we've deployed elements of the blockchain network. There's a thing called a fabric here. Now, the fabric is a construct within Apache Brooklyn itself, and what that means is a cluster of clusters. The reason they're connected is and wired up so elegantly is because what BlueBox did was surface the private backbone that exists throughout the world on SoftLayer and expose that as a private shared network within OpenStack. So technically what that means is that essentially we can connect virtual machines running anywhere in the world through that backbone, so without even having to go out on the internet. So if you're creating a permission business blockchain and you want to roll it out globally, this is a very, very solid solution.
So yeah, I want to show you something else that Duncan mentioned. So basically, okay, let's make this a little bigger. So basically right here, I've actually logged into one of the validating peers, and we can see here a bunch of containers running. Excuse me. One of the containers running is the validating peer itself, and other of the containers are actually chain codes, smart contracts, living pieces of code that actually make this useful. They're also running as containers. These are running on all the validating peers. I've logged into just one for time. And you can see these are just different runs I've done over the course of the past couple days. This top one right here, this one right here, is actually the chain code that I'm going to live demo for you right now. This is a smart contract that deals with the art, auctioning, and asset management. So we're going to be running against this actual container.
This is a great example of how you can actually host or manage multiple blockchains or smart contracts in the same Hyperledger Fabric. Really important, otherwise you end up with just case-by-case environments, and it's very, very expensive in terms of scale.
Yeah, and so basically each of these, I suspect, are in fact the same chain code being run differently, but of course in those chain codes there's entirely different asset states. This could have Alice with all of them, this could have Bob with all of them, doesn't matter. Like, they all exist separately and securely. So now to actually show you it running. We've got three terminal windows here. Basically, I've written a small app that basically interacts with this chain code. You can log in as one of the authorized users that Membership Services knows about, and then you can interact with the chain code doing the assign, the transfer, and the query. So we've got Charlie, Dave, and Edwina here, and I've already fired this up and run the list command, which basically queries to see what each person owns. So we've got Charlie, Dave, and Edwina, and they each own a third of the 47 pieces of art. If this is too small, it's no problem if you rush the stage. I've got these so perfectly oriented that if I do the plus, it's going to mess it up. I don't do that. So
you'll notice we've spent no expense spared on the user interface here.
Oh yeah. It's a tech conference, right? It would seem suspicious if it looked too fancy. So
what are we going to do? So is Charlie going to loan something to Edwina? Or?
Sure, yeah, because unfortunately, 47 divided by 3, as you mentioned, is not even. Arbitrarily, Edwina got one less. Okay, I don't want to get any so let's transfer one over there right away and let's get that worked out. So let's transfer. I'm going to type this very carefully because my product manager, error handling is on the roadmap, so I got to make sure I type this in right. Transfer, let's go with lot, I don't know, how about lot 1? Easy. We'll transfer lot 1 to Edwina. Transfer lot 01 to Edwina. Cool. So Hyperledger takes a few moments to reach consensus, so I'm going to stall for about 5 seconds.
So amongst yourselves, okay.
And then I'm going to check with, yeah, cool. So now let's list Charlie, and we should see that lot 01 is not in his list anymore because he doesn't own it. It is gone. Now let's list Edwina, and we should see Edwina now is a proud owner of Bernard Leach's vase with leaping fish design. And she's going to cherish it for many years.
Dave hasn't got it as well?
Well, let's make sure Dave doesn't have it. Let's definitely do that, and make sure that Dave does not have lot 01. Cool. Let's also see if Dave wants to be a sneaky little guy and try to actually transfer, or I guess if he wants to try to give his buddy Charlie lot 01, he should not be allowed to do that. So if we transfer lot 01 to Charlie so he can sell it again, he should not be allowed to do that because he does not own it. Dave is not the owner of lot 1, and transfer is not allowed. So that works. And basically, this is all going against the chain code we have there before. And actually, I want to do one thing real quick, just to give a little proof. So I'm going to exit up the Charlie client, and I'll show you the command that I run just before this. It's being clipped, unfortunately, but basically, I'm running the app, and I'm giving it the name of the chain code so it knows what to run against. So if I copy that, and I go over here, we should be able to see, yes, it was clipped, but that's part of this chain code, so it's running that. So obviously, it's not just a script I wrote last night that prints gibberish and holds the stuff in an array. Because you can see right here, it actually...
That would be really hard to do, right? And a waste of
time. Yeah.
Smart engineering talent to fake it if you can do it for real.
And of course, you're probably thinking, okay, well, couldn't you have just written your own little Docker program that has a PS and then prints out these hard-coded things? Yeah, that's what we did. It's all fake, so... perfect.
This is the fire hose of truth, which whenever you're doing a demo with an engineer or you're a client side with an engineer is the point at which I just curl up and die. Well, thanks, Mike. So I think, if we can just roll back to the slides for a second. What I think we want to stress to you guys is, yeah, of course, this is a noddy demo, but even so, it's building on an asset management demo that's already been contributed to the Hyperledger Fabric. And once we tidy this up, the idea is we're going to contribute it back and also work on it, because there's a couple of things that we're doing in the not too distant future. And brief advert, if you want to try it yourself, just this is one of many places you can go to, but if it's convenient, go to the IBM Marketplace and just search for blockchain, and you'll find there's now about half a dozen services that all provide different aspects of blockchain. So we're there. It's an easy way into just finding out a bit more about what we're doing. You can also just go to cloudsoft.io/get HLF. HLF is Hyperledger Fabric. We'll be at Blockchain on Wall Street in a couple of weeks' time. If you happen to be in the neighborhood, I really recommend you go to this. It's a great way of learning, scaling up to speed what's happening in the industry, looking at Wall Street specifically. And not only that, it's designed to be an education day, so it's all about cluing people into this technology. And so there'll be panel discussions about practical implementation choices, et cetera, and of course the role of open source in all of this. And finally, and this is something I think is really important to understand, and it ties in with the notion of the work the Hyperledger project is doing, of which Fabric is just one example, and the Linux Foundation and the Apache Software Foundation. We think blockchain technology is too big to be owned by a single entity. So it's something that we should own in common and be able to work on and collaborate on in common. And then we go off and do our own thing, and we create our own applications, and of course, everyone can then differentiate. But the core, the substrate, just like the internet, is something that we honestly believe should not be owned by a single entity. So with that, here are the links, and I think we're just about out of time. There's literally 2 minutes for questions, but I don't want to hold up the next speaker. Eric, do we have time?
Yeah, sure. Is there a question? You take a question. It's early, so people are like, questions, cameras.